So I'm starting the recording now, and we're working on the pixel filling algorithm, which I had described in the back. And I'm going to build it, and we'll talk about it as we go. The first thing that I'm going to do is I'm going to go ahead and put in my main, and then I'm going to declare the grid. I want to set up the grid, and because this is Java, I'm going to make it a two-dimensional array of strings. I prefer to use characters, but Java and characters don't get along. And so I'm just going to set this up with a new size, and we'll do something slightly large. Actually, this is actually very tiny, but for our screen, 20 is a little bit big. And then I'm going to do a couple of maintenance things. I'm going to init the grid. I'm going to have to set it to a bunch of blanks, right? So public static void init grid, and this thing will take a two-dimensional array of strings. And then I'm just going to do a nested for loop. Remember, if you're going to go through an array, for loop's the way to go. Of course, this thing needs a name. And so I'm going to do grid length. Now, if you remember, for two-dimensional arrays, a two-dimensional array is actually an array, right? So the word grid is actually talking about one array, but every element in that array is an array. So in Java, a two-dimensional array is actually an array of arrays. So I'm using the name grid and length. That gives me the height. And then if I want the width, what I need to do is pick one of the arrays and get its width. Now in Java, you can make each array its own width, which is called a jagged array. And that's fine, it works just fine. But so in other words, in order to implement that, I'm going to do grid at I, which is the current row, and I'm going to use the length of that. Now, if this turns out to be a jagged array, which it never should be because I'm not going to let it be, then it's going to be messed up, right? But I know that it's 20 by 20. And then, so of course, now you know what I'm going to do. I can't help myself. Public static final int width equals 20. See, these things just, you can't stop yourself. And that's good. That's how wide they are. And then the same thing for height. Because I hate using the numbers. I felt like I was in a little bit of a hurry, and it would go faster if I didn't do this. I just can't stand it though. All right, and so now what I want to do is I want string at I, J. I'm sorry about that noise. Somebody is doing something in the kitchen above me. And not string, I'm an idiot. Grid at IJ. And I want this to equal a blank character. Well, let's set that up. And I just want it to be a spacebar head. And this way I can change it later if I want. So now we initialize them all to blank, and we're good. All right. And then I'm going to need one called filled. And we'll just pick a character for that. I usually do asterisks, but they look pretty small. Let's do something bigger, like pound signs are pretty big. I know they're called hashtags, but they were called pound signs before they were called hashtags, and I'm an old fart, so there it is. So anyway, now I also would like to display the grid. And this is going to just show the grid on the screen. And the nice thing about this is that it's essentially the same thing. So, and except in this situation, what I want to do is S out. Grid at ij. And then I want to make sure that after every row, I just print a blank line. All right, is everybody with me? These are just setup methods. Anthony, you doing okay? It's not exciting stuff. Hopefully the review of two-dimensional arrays is a little bit helpful. But without these, it's kind of hard to know what to do. And so now here's what I want to do. I have this two-dimensional array of spaces. What I want to be able to do is I want to be able to make a shape just to demonstrate how this works. And the easiest way to make a shape is to just draw horizontal and vertical lines and make a rectangle. Okay, so I'm going to make a method that allows me to draw a vertical line, and then I'm going to do another one that allows me to draw a horizontal line on the grid, because if I have that, then things are a lot easier. So I'm going to say draw vertical line, and then what I'm going to do is give it grid, which is what I'm drawing on, and then this is going to be a vertical line, so I need to indicate what column I'm on. Okay, and then I'll do the same thing, but I'll do horizontal. And this will be row. Okay, I know those are not done correctly yet, but I'll fix that in a second. So I'm going to put these two down, the display grid and the init grid. Actually, oh wait, hold on. You're right, on this one I don't. That was on line 29. Thanks for telling me that. You're absolutely right. That would have made it all go really vertical. So appreciate that. So actually, you bring up a good, you remind me of a good point. I should at least run this once to see if it works. And what am I going to see? Hopefully a lot of nothing. So notice how the build is way at the bottom. If I select, you see how I'm selecting nothing? That means I'm printing a bunch of nothing. It looks like 20 is a little too tall. So the nice thing about this is I can bump it down. Let's just do 15 and see if that's better. There, now I can see the whole thing. That's nicer. And then also, if I want to, I can put a dot here in blank and sort of do a test case there. So it's printing them all. So I know that it's actually doing what I want it to do. So that's kind of neat. All right. So that's all working the way I want it. Now let's unselect this, or sorry, uncomment it. I'm going to put these two right here. I don't really have a better thing to do with them. And I'll make these void again. There's not really a desperate need for them to return an answer. The second one is an empty column. Now, oh, there we go. And since I like all of that, I'll copy it, just paste it over that, and change. There, so that's good. And just to make that shut up, I'll put a 4-4, and now that won't give me any arguments, and I can test it a little bit later. Now, remember, one of the lessons that I continuously give about using parameters. I have received a parameter. Oh, and for this one, I want that to be row. I've received a parameter, and I'm accessing a grid or an array. This is actually a position that somebody is telling me they want to use. Well, the very first thing I'm going to do is not trust them. So I'm going to say if column is less than 0, that means it's not a valid column. Or if column is greater than or equal to width, then it's not valid. So I just check to see if it's bad, and if it is, then I bail. It's like I could have made it a Boolean and return true or false. I don't really care at this point. You all know how to do that. I'm just doing this a little bit quickly. So after that, I will simply set up a for loop. I know that this is valid, so I'm doing a vertical line, so I think I should do height. Is that right? No, it's vertical. So I'm checking this on the width, but this goes to the height. All right. Pondering while I go. So from 0 to height, I want to print, and what I'll do, I don't want to print, I just want to set. So I set grid at column, no, grid at I, that's how far down I am. At the column that I wanted, that's, so the I is how far down I am, that's what row I'm on, and column is how far over I am. And I want that to be set to filled. And that's it. For the draw horizontal line, I do the same things, but for row. But in this case, I'm checking it versus the height first. So I got to make sure that it's between 0 and height -1. And then here, I would do width. And here, I would say pardon my throat. I would do the row and I would shoot across. All right, are we okay with this part now? Can I get a quick thumbs up if you're okay? Good, everybody's keeping up. I don't see any questions, but Anthony, I do appreciate you bailing me out. And so now let's just do a quick test of this. We will do one grid displayed blank and the other one displayed with with the grids filled in, and hopefully this will look good. It looks good so far. Okay, come on. And so nice. Here's the blank one. Here's the one with 4 and 4, right? And it's nice that we have 4 and 4. Let's make 2 more. For the vertical line, I can go over a little bit further. So let's make that one like 15. For the horizontal one, I have less room. Let's make that 10. And now I should have a great big hashtag looking thing with a nice rectangle in the middle that I can run the flood fill algorithm on. Pow. So what I'm going to do is show you how this middle section here, actually this is kind of cool because I can do annotate. This section right here, we're going to fill that one in. How do you like that annotation? Pretty badass, huh? You don't have to answer, it's okay. So eraser that. And now let's get off of the annotation here and get back to work. All right, so this is all pretty cool. We got some nice stuff. Now it's finally time void, we'll do flood fill. Okay, now the flood fill is going to need the grid. Okay, and then it's also going to need the current pixel. So the row that we're on and the column that we're on. These are the things that we have to know. So what I want to do is these three things. So we can start with this pretty easily. I can say if grid at row column, right, dot equals filled. If that is true, then the place that I started is already filled and I'm done. This is our base case. I want you to notice that this is going to be checked every single time this method starts. So when we initially start from main, I'm going to give it a starting point. And that represents where somebody clicked with the bucket tip. That's going to be the very first one we check. And if they click on a hashtag in our grid, then it's just going to stop because there's nothing to fill. If they click, what I'm going to do is aim for this space in the middle. If they click there, then it will fill everything. Well, while it's filling, the spaces are going to be placing hashtags and then checking their neighbors. Well, of course, when this happens, they're going to check places that have previously been filled, right? And we need those to, so we have to check this right away. And the moment we determine that we're not filled, we need to fill the space. So grid at row and column is now set equal to filled. So fill yourself right away. All right, and that's step 2. And now we're ready for step 3. And this is how we're going to have to do this. In order to check up, it actually took me an embarrassingly long time to remember how to spell neighbors. I spelled it wrong many, many times before I got it right. So first, let's check up. Well, this is our recursive call, flood fill. And in order to check up, we need to have our row -1. So we give it grid, but we don't give it row, we give it row -1. And then we give it the same column. and this checks up. All right, everybody with me on this? Amber, Anthony, you doing okay? All right. And then we'll repeat this, checking down, left, and right. In order to check down, we will add one to row. Okay. In order to check to the left, we will leave row alone. And when we want to move to the left, we have to go -1. That moves us closer to 0. And then to check to the right, we need to do column +1. Oops. And we need to take away the nothing from row. And if we implement this, if it works, of course, you know how I go there. The moment I write code, I assume it doesn't work. But I'm going to plunk one in the middle, and we'll see if it fills. And let's do this. We have displayed the grid, right? Now let's do flood, fill, we'll give it grid. And I want to make sure that it lands in that space. So both of them have to be greater than 4, and one of them has to be less than 15, the other has to be less than 10. So I'm going to do 8 for both of these, because that's both in that range. 8 and 8 are both in the range. And then because I've written my superfine display grid, I can just display the grid when we're done, and we can see if it worked. All right, can I get a drum roll? Okay, good enough. Now let's run the file, and there it filled. And so notice we have the blank here. We have the thing here. I should have put an extra space here to separate the hashtaggy looking one from the one with the filled, but notice that it just went through the whole thing. All right. To make this look a little clearer, between each of these displays, I can, well, actually at the end of the display, I can simply do this twice. That's easy enough. It's quick and kind of cheap, but that's okay. That's not where I wanted to do that, by the way. I meant to do that here. So that's kind of funny. There we go. Now there should be a little bit of separation right there. Okay. Does everybody understand this situation? Anthony, you okay with this? Okay, now, excuse me. What is actually happening here is kind of interesting. I'll take some space right here and draw it. So let's say that we have our hashtags here, pound, you know, like this. It's going to take just a little bit of time, but I think it'll be worth it. Trying to get the same ratio here, ratio, whatever it's called, the same width. All right, that's sort of close enough. So let's say we click and we start right here. This is clearly blank. So what happens is we have this position, and let's just go ahead and do 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, and 5. It's a little bit there. That's 5. So if we go right here, then we are at position 1, 2. And that does not base case, so we fill it in. When we fill it in, the next thing that we do is right here is we check up. Are you able to see me very well, or do I need to release the screen and make my board bigger? Give me thumbs up if you want me to close NetBeans and make my board bigger. Okay, let me do that for a little bit. I'm going to stop the share for just a little bit. Anthony, I just want you to be able to see. Hopefully I'm bigger now on the screen, and this is a little bit easier to see. Oh, and I realize I went off the screen on this side, sorry. So this one is 1, 2, and main is above it in our stack, okay? These are stack frames, main just called 1, 2. Now 1, 2 is doing its 4 checks of the neighbors. And we decided to go up. So it will go up and it will call 0, 2. And 0, 2 will immediately base case. It will base case because at position 0, 2, there's a hashtag. So it's filled. When we come back, 1, 2 will then call down. And that will be 2, 2. And 2, 2 will put a hashtag in, and then 2, 2 will call up. All right. So the top one is waiting for the for down to finish, and this one goes up. And when it goes up, it does 1, 2 again. Right. So this is where it's really fascinating when it comes to what's happening in the stack. We have 2 instances of this method, both at the same place, but the first one found it blank and filled it and started having it check its neighbors. The second one found it filled, so it base cases. This is why it's critical that you fill it right when you find it blank. And because when 2, 2 checked up, that one base case, it pops off. And now 2, 2 goes down. I may have made this a little too big, but we've got 2, 3. 2, 3 does this, right? It checks 2, 2. 2, 2 base cases. Now 2, 3 checks down. That's going to be 2, 4. I got these backwards. 3, 2, sorry about that. And this is 4, 2, right? 4, 2 checks 3, 2. 3, 2 base cases. Then 4, 2 checks down. Well, when it checks down, it gets to 5, 2. 5, 2 base cases, right? So when 5, 2 base cases, we come back to 4. Now 4 checks left. When 4 checks left, it's going to check 4, 1. Right? Does this make sense? And so what will happen is 4, 1 will fill itself and check up. And then 3, 1 will fill itself and check up. And 2, 1 will fill itself and check up. And 1, 1 will fill itself and check up. This will base case. Then 1, 1 will check down. That will base case. Then 1, 1 will check left. That will base case. Then 1, 1 will check right. That will base case. And then 1 will finish and pop itself off the stack because it finished. Then control will come back to 2, 1, which is already checked up here. 2, 1 will check down. Base cases. Check left. Base case. Right. Base case. It will be finished. Pop off. 3, 1 is waiting for up. Then it will go down. Base case. Left. Base case, base case. This one will bait and finish. And then finally, we'll get back to 4, 2. 4, 2 will check right. And right will go up, up, up. And then this one will go up and it will base case. It'll go down and it will base case. And it'll go right and it'll base case. And then it'll go here and find an empty space. And this will go up and it will base case. Then it'll go down, down, down. And then all these will base case. All these will base case. All these will base case. This will finish. This will finish. This will finish. This will finish. And then it'll work all the way back up to that starting point, and all of them will have finished. And all of that work happens on the stack. And it happens, if you look at our code, it happens. I'm bringing the share back up. All of that work happens in what? 7 lines of code, right? That is where recursion becomes very powerful, because you can do a very intricate job filling in a weird amoeba-like shape with 7 lines of code. And it utilizes the stack, and this technique of moving into a space like this shape, filling in the nooks and crannies, and then backing out of them, that's called backtracking. And it's the last bullet on the topics list for recursion. That just one word, it just says backtracking. That's backtracking. And that's one of the most common examples of backtracking, and it's also pretty damn tricky to learn at first. You can use backtracking to do all kinds of things, not just filling in spaces like that, but it's often used to solve mazes, because you basically move through the maze the same way you do this. When you hit a dead end, everything around the current space base cases, and you just back up and have them check other paths. But all of it is happening on the stack, okay? Let me bring up the chat went away again. Every time I start this up, I gotta restart the chat. Okay. What do you think of that? How'd that go? Okay, I have one last thing to talk about when it comes to this. You will notice in our output that I didn't say what would happen if we filled in one of the areas that's on the edge of the screen. For example, what would happen if I put a pixel right there? I don't have a top. Same with these other spaces all the way, you know, all these other spaces, they don't have this nice contained feature. So what would happen? If I put a pixel that wasn't in my box, then I would go off the screen and crash my program. Sorry, I'm not good at drawing arrows. I'll work on that. Okay, so this is a real problem. If I'm flood filling and I go to the edge of the grid and I go off the grid, then I'm going to get an index out of bounds exception and crash my program. So it turns out that having the pixel be empty is only one base case. There are actually 4 more. If I go off the screen, up, down, left, or right, okay, then I'm also going to want to base case. So I will add those just to finish this off and make it so that this algorithm will work. Oh, I did the stop annotation, but it didn't clear the screen. Here we go. Clear is easier. Clear all the drawings. All right. And so base case is this space already filled. I want to check the neighbors, or check to see if I'm off the grid first. Because if I'm off the grid, I do not want to check using the grid. So before I even do that, check to see if it's on the grid. And so, oh, I don't want that to be a comment. If, and now I just got to do these 4. Let's check up. If row is less than 0, then I'm off the grid. or if row is greater than or equal to height, right, then I'm off the bottom. And I can check all 4 of these with one Boolean. Or, now we'll check the column. If column is less than 0, then I'm off the left-hand side. Or if column is greater than or equal to width. And now I can return. I could actually combine all of these and put this in with this, but it makes it a little bit harder to read. So now I've got all my base cases, and now when I run this, I can fill one of the spaces that isn't the center space. And let's do that right quick. Okay, let me actually change the number so that it does that. Let's fill the top left one, because I know that doing space 1 and 1 would fill this area right here. And then there it is. Okay. So that's that big example, Anthony. What do you think? Amber, what about you? You guys got any, type in any questions in the, or any comments, anything you want? That's the end of this example. And I'm actually going to stop recording now.